Chapter 6.6, Solve Radical Equations. So let's dive right in and begin with an example of the cube root of the quantity 2x plus 7 equals 3. So first, let's cube both sides. This will eliminate the cube root, so we're left with 2x plus 7. And cube the 3, which is 27. Now, simple algebra gives us the answer of 10 for x. Let's do a similar problem of solving x plus 2 raised to the 3/4 minus 1 equals 7. So we're going to do a similar method of getting rid of this exponent by multiplying everything on the left side. Well, actually, I take all of that back. We're going to first add the 1. So we just have x plus 2 to the 3/4 equals 8. And you could really do it the other way too, with leaving the negative 1 on the left, but it does simplify things to leave it, or to add it to the right. So now we can raise both sides to the 4/3. This will cancel out this exponent here, so the 3's and the 4's. We have simply x plus 2 equals 8, and we can write 4/3 as 8 to the 1/3 raised to the 4th, if you remember our properties of exponents. So 8 to the 1/3 is 2, so we have 2 to the 4th on the right, and on the left we have x plus 2. Simplify this and we have x equals 14. Now we're going to do the exact same type of problem, except this time we're going to have more than one answer, and therefore extraneous answers or solutions. So we're going to solve x plus 1 equals the quantity 7x plus 15 times 1/2, or the square root of 7x plus 15, because remember, this quantity is also 7x plus 15 raised to the 1/2. So either way, we're going to be squaring both sides. So we have x squared plus 2x plus 1 equals 7x plus 15. Put everything on one side, so we have x squared minus 5x minus 14 equals 0. We want 0 on one side. Then we can make this polynomial into its zeros, so x minus 7 and x plus 2. We're going to factor the polynomial, and each of these is a 0. So that means x minus 7 equals 0 and x plus 2 equals 0. Therefore x is 7 and x is negative 2. So we have two solutions for this problem, but we're not done yet because we need to plug them both back into our original problem. So with 7 we get x plus 1 equals 7x plus 15. This is our original problem, and we're going to plug 7 in. So we have 8 equals root 64. Root 64 is 8. 8 equals 8. This we can verify is correct. Now we take our negative 2 and do the exact same thing. But our final answer, we have negative 1 does not equal 1. Therefore, this is not a solution, and our solution is simply x equals 7. So whenever you have more than one solution, we need to check it by plugging it into the original equation. So up until this point, we've solved equations with simply one radical, and now we're moving on to two radicals. We're going to approach these problems very much the same way as we did with one radical. We're going to square both sides to get rid of our radicals. This leaves us with x plus 2 plus 1 equals 3 minus x. False. This is what we would think we would have, but we need to treat this as just as if we're multiplying x plus 1 squared. So this is actually not this answer, but instead, let's write it out. We have x plus 2 plus 1 times x plus 2 plus 1. And now you'll see that it's not just this as our answer. We have to FOIL. Once we FOIL this, we have x plus 2 plus 2 times root x plus 2 plus 1 equals 3 minus x. So this is really 3 minus x on this side as well. And then on the left side, we are left with 2 x plus 2 equals negative 2x. This is after simplifying algebraically. And then we were going to divide by 2. So we have x plus 2 equals negative x. Square both sides. And we simply have x plus 2 equals x squared. We want to get everything on one side, so next we have x squared minus x minus 2. This gives us the zeros of x minus 2 times x plus 1. Then we have two solutions, x equals 2 and x equals negative 1. And then we're going to check these. So when we plug this in, we get 3 equals 1. This is not true, it's not a solution. When we plug in negative 1, we have 2 equals 2. This is a solution. So x equals negative 1.